So last day in class you learned what a linear system was, and to refresh your memory, a linear system is a set of two lines, and to solve a linear system means to find the point of intersection of the two lines. Last day you figured out that point of intersection by graphing, and today what we're going to do is learn an algebraic method in order to find the point of intersection. There are two methods, substitution and elimination, and we're going to start with the substitution method. So there are a series of steps to go through. We'll go through this slowly and do a few examples together, and then you can try a couple of examples on your own afterwards. So when you solve linear systems by substitution, the method is often used if one of the equations is in y equals mx plus b form and the other isn't. So if you can see, this equation is in y equals mx plus b form, and this equation is not. That is a case where you would definitely want to use the substitution method. So the first thing you're going to do is to label each equation. So we're going to label this equation number 1 and this equation number 2. Then what you're going to do is take this one here, the one that's been solved for y. So you're going to take equation 2 and substitute it into equation 1. That means this x plus 1, which is equal to y, will be substituted with that y. Because the point of intersection, these two y's are equal. So if y equals x plus 1, this y would also equal x plus 1. So your first equation is 2x plus this x plus 1 equals 7. So y was equal to x plus 1. So this is saying 2x plus y equals 7. Now what you do is you're going to solve this equation for x using your grade 9 equation solving skills. So what we're going to do is remove the brackets. So it's 2x plus x plus 1 equals 7. Collect like terms. 2x plus x is 3x. Then you're going to subtract 1 from both sides. And then lastly, divide both sides by 3. So that means the x-coordinate of the point of intersection is equal to 2. So that there is the x-coordinate of the point of intersection. All right, the next thing we're going to do is we're going to take that x equals 2 and you're going to substitute it into one of these two equations. The easier equation would be number 2 because it's been isolated for y already. So we're going to take that x equals 2, substitute it into equation 2 so that we can figure out what y is. So equation 2 was y equals x plus 1. So you're going to substitute that 2 into the x. And 2 plus 1 is 3. So that is now the y coordinate of the point of intersection. Finally, what you have to do is to put your answer as a point. So the point of intersection is at 2, 3. So it's very important that you have that therefore statement to give the point of intersection as a point. Now, you can check your answer by taking this point and substituting it into equation 1. In order to check your answer to see if it's correct. The reason we're using equation 1 is because we already substituted the x into equation 2 to get our value of y. So we want to know that if we substituted those points into equation 1, we would get the same value. So the equation 1 was equal to 2x plus y equals 7. To do the check, you're going to use this little t-chart here. The left side was 2x plus y, and the right side was 7. So we're going to substitute 2 in for x and 3 in for y, and check to make sure we get 7. So 2 times 2, x was 2, plus 3, so that was x, that was y. Using BEDMAS, 2 times 2 is 4, and 4 plus 3 is 7. So your left side of the equation equals the right side of your equation. Therefore, we know for sure that the point of intersection, you can use POI for short, is in fact 2, 3. So this step 7, you really only have to do if you want to check to see if your answer is right, or if the equation asks you to do a check. So if the equation asks you to check your answer, this is what it means. So because this is a complicated method, we're going to do quite a few examples in this video, so this video will be a little bit longer than you're used to. So here go with another example. Sometimes neither equation is in y equals mx plus b form. So you can see neither is in y equals mx plus b form. So it doesn't mean you can't use substitution. You can use substitution if one of the terms has a coefficient of 1 or negative 1. Now remember, coefficient means the number in front of x or y. So that's 2x, that's 5y, that's 2y, and this is just x. So that's basically 1x. So that means, because we have a coefficient of 1, this would be a good question to use substitution on. So let's label this equation 1 and equation 2. Now what we're going to do is take this equation number 2 and isolate it for x. So whichever variable has the coefficient of 1 or negative 1, that's what you're going to isolate. So you're going to isolate equation 2 for x. So equation 2 was x plus 2y equals negative 6. So to isolate x, it means we want to get rid of this 2y. So we're going to subtract 2y from both sides. And we get x equals negative 2y minus 6. So we have isolated equation 1 for x. Now what we're going to do is take this and substitute it in the x in the other equation. So take this expression that's equal to x and substitute it into the x of the other equation. So we're going to substitute equation 2 into equation 1. So we're going to have, instead of 2x, it's going to be 2 times this expression plus 5y equals negative 18. So remember, this expression was equal to x. So we have 2x plus 5y equals negative 18. We are now going to solve this equation for y using your grade 9 equation skills. First step, distributive property. So we have negative 4y minus 12 plus 5y equals negative 18. Collect like terms. Negative 4y plus 5y is 1y. Now add 12 to both sides, and that will give you y equals negative 6. So that's the y coordinate of your point of intersection. Now substitute y equals negative 6 into any equation. You can do equation 1, you can do equation 2, or we can do this rearranged equation here, which you can call equation 3 if you want to. So we're going to take that, substitute it into equation 3 to solve for x. So equation 3 is equal to x equals negative 2y minus 6. And we know that y is negative 6. So it's negative 2 times negative 6 minus 6. Negative 2 times negative 6 is 12. And 12 minus 6 is 6. That's the x-coordinate of your point of intersection. So your therefore statement, the solution is 6, because that was your x value, negative 6, because that was your y value. So always remember, the x value comes first, the y value comes second. In order to check your work, you're going to use the other equation. So we used this equation right here to solve for x and y. So now we're going to use the first equation. 2x plus 5y equals 18. So the left side was 2x plus 5y, and the right side was negative 18. So substitute the point in. 2 times 6 plus 5 times negative 6. That's 2 times 6 is 12. 5 times negative 6 is negative 30. 12 minus 30 is negative 18. And since your left side equals right side, you know that your equation is correct. So we're out of time for the first part of the video. Please be sure to watch the second half of the video.